suspended in a liquid or a gas.
Okay, so you're looking at it. You're looking at it from that angle. All right. So, all right, fine, fair enough.
Suspended in a liquid or a gas.
Okay. Okay. So you're looking at it. All right. Yeah. All right. So we're looking at something then, and it's basically a mixture where you see more than one things present. All right. It's as you say, you know, that's suspension. It's mm, yeah. So particles are suspended. Um, right, from are suspended from a solvent. Yeah. So that's so it's used to separate, and this is a crucial thing because you have to know what type of mixture you have. Filtration is used to separate a suspension, and then when it separates it, you say you get the two things. You say you get a residue, and we get a what's the other part, um, and get a filtrate. All right, crucial though. Have to know what can be filtered. All right, so now know that you can filter a solution. All right, all right. A solution cannot be filtered. All right, and all right, I know that's ideally. All right, so it basically means that like for example, if you have salt and water, you cannot filter it. If you have sugar and water, you can't filter it. All right, because those two things dissolve in water, and those particles not only do they dissolve in water, they are too small to be filtered, so they will actually pass through. So we have to find another way to separate those, but it's not filtration. So first thing, before you try filtration, you must determine so well it's a suspension you're working with. All right, so that's the idea. Any questions here? All right. So then all right. So let's see who else is in the waiting room. Filtrate and residue. All right. Did we look at any other technique?
Sorry, can I go back 1 minute, please?
What's that, Lamar?
Sir, I'm writing.
You're writing. Oh, so and you go back to the original.
Yes, sir.
All right. Yeah. So remember, did I give you a list of the techniques you're gonna do?
No, sir.
All right. Well, so filtration is the most basic one. Did we do? And somebody said we did which one last week? Distillation.
Yes.
All right. I'm going to you have simple distillation, and we also have fractional distillation. And there's actually a difference between the two. All right, let's see. We can confirm that this evening. All right, but there are about, well, I'd say 5 of them, that we need to know very well for CXC purposes. But then there are about 8 basic ones that you're expected to know. All right, and all right, persons are still writing off what's on the screen.
No, sir.
All right. So let me know when I can move on. So because filtration 1, 2, 3, 4. Yeah. Filtration, simple distillation, fractional distillation, and we have quite a few more. But for CXE purposes, these 3 and number 4 would be crucial as well. In terms of SBA purposes, we would have to do something on filtration. Distillation and fractional distillation, it's not compulsory for the SBA, but they expect you to at least see a demonstration of it and to be able to explain it. So we're going to do that. And then number 4, which round up this list, which is also compulsory, because they recommend that we do at least 2 anyway. So, and this is 2 where we actually assess you for carrying it out, in real life. So like we mark you for how you carry it out. So filtration and chromatography are 2 crucial ones. Simple distillation, fractional distillation are, like, as we say, expected to know it. But then if we do at least 2 separating techniques, then we're okay. If we were gonna do 3, then distillation would be the 3rd. But then so let's move on here, because we're gonna look at all right. So that's filtration from last class. Remember, now I should also point out couple of things about distillation. What did I show you a demonstration of distillation last class?
Yes, sir.
Okay, good. And was it a video? Or was it a diagram?
Diagram.
Diagram, sir.
It was a diagram. All right. The distillation videos, I'm interested in those. I didn't like the ones I saw, but let's see. I did show you a setup that you could use for home purposes. But all right, let's see.
Yes, sir. Yes, sir. The pressure cooker.
Oh yeah. Okay, that's a home setup. All right. Fair enough. Let's bring up this visual here. All right. And so let's look at what simple distillation is, so we can go through this quickly. This, I'm gonna change this screen now and see what happens here. Let's just pause that for now. And I'm gonna send you to look at this screen. Everybody seen?
Yes, sir.
All right, and everything is optimized here. All right, good. So let's have a look at what's happening here. All right.
Excuse me, sir, the video is mute.
Yeah, I know. We don't need the sound right now. All right, it's more looking and observing. All right, so again, they look like they use Powtoon to design this thing. So it's lovely animation here. All right, now let's carry it back to
simple distillation.
all right.
I need to remove this nail polish. Nail polish can be removed by acetone. Acetone can be obtained by simple distillation.
The process of heating a liquid mixture to form vapor and then cooling that vapor to get a liquid is called simple distillation.
All right, so yeah, stick up in here. All right, so working with this definition here. All right, process of heating a liquid mixture to form vapor and then cooling that vapor to get a liquid. Definitely, that's explaining the process in detail. All right, so again, we say it involves a two process them, which is in evaporation and condensation. So still go back to those processes there. All right, so it's evaporation and condensation, and all right. No. And so working with that definition, and when you go back to the screen, you see me simplify it there. But you can I continue?
Yes, sir.
Okay. All right, let's go. All right.
Distillation is used to purify a liquid by separating the components of a liquid mixture.
All right. Let's make a note of that because that's that might be crucial here. Purification. So definitely one of the process used to purify. All right. So now remember that, and that's one of the reasons why rainwater is considered a good source of water. We know where water has been. All right. People say that why you can't just use rainwater without boiling it and so on. But in nature, we go through natural distillation. Remember, it is just evaporation and condensation. So in other words, the sun heat up the water, turn into vapor, and then it basically condenses as rainfall. And so we have that water cycle that we learn about from even grade 4. All right. So it's the same thing. Now, if you're using things like if you're using water to put in a car, for example, as a coolant, or using water in your iron, for example. All right, how many of you use pipe water inside your iron? That's for those who iron clothes anyway. Anybody use pipe water in the iron?
Yes, sir.
Yes, sir.
Okay, that's nice. That's nice.
So I heard that it mash up the iron or something like that. Like chlorine.
Yes, sir. That me here too.
Yeah, it is not recommended, and that's true. And well, chlorine really get a lot of bad name in chemistry. Chlorine is not as bad as what people make it out to be. It's not like it's in water, but it's not what you see. You cannot see the chlorine in water. What you're seeing is not chlorine. All right, you're seeing most of the time what people call chlorine is actually the calcium carbonate sediments. And the main thing about chlorine is that, well, number one, chlorine is not very soluble in water. I mean, if you heat water, then chlorine will actually leave. All of the chlorine will leave. But then what leave behind is that white scale that you'll see that that leave in a kettle or any container that you use to boil water. You're always gonna see some white scale leave behind. And that is the culprit for giving water the color and doing all sorts of things that people say, so that water there. So that's pointing out to say that the water that you get from the pipe, it has not been distilled. They use a different process to clean that water. And that's the problem. That process that we use to clean the water, it is not, it still leave behind some bacteria. Right? As a matter of fact, it's some almost like a river. It's them use something similar to osmosis to purify water. So them pass it through a lot of filters at the NWC water treatment. And that's one of the main reasons why the sewage is actually connected, because the sewage is where you actually get your water from, believe it or not. So people think they get pure water. Okay, fine, it's pure enough, but it's not pure. By chemistry standard, it's not pure. Right. So what they do now, every water that you use, and they have the drainage system that connect back to the water plant, the water treatment plant. The water treatment plant does a sort of filter in there. And that's the reason we use filtration. Remember to remove a suspension. So anything solid in water will be separated there. So the most obvious things will be separated. And of course, the water now will probably have a sort of murky color. And you have to go treat that now. Filtration, but this time you're going to use like something very fine to filter out that. And then afterwards, the final step is to put some chlorine, but it's a small amount of chlorine in the water to kill the bacteria that's there. And it has to be a certain amount of chlorine. So they test the water before them send it out. All right, two things have to happen before you get that water through the pipe. One is that they have to do a bacteria test, and the other thing is they have to do a chlorine test. All right, now passing those two tests now ensures all right, the water can be pumped safely to your house. And then any pollution that takes place afterwards might be due to the pipes they might use to string up your house. So maybe some want to use metal pipe, some want to use plastic pipe. All right, so that's where the contamination will come from. But saying this to say that the water at home, it's treated water, different from distilled water. And like, you probably can't tell the difference, but trust me, things like iron and your car can tell the difference when you use it. Plants can tell the difference too, because if you have two of the same plants and you say, all right, I water one of them with pipe water and you go water the other one with rainwater, which one you think going to grow better? Which one you think going to respond better? The one with the pipe water or the one with the rainwater?
One rainwater.
Water, sir.
Well, yeah, plants know it. You can't trick the plants. Can't trick you. I mean, I cool and water can trick you. 876 water can trick you, because you just go spend your $50, $100, buy one bottle of water, and then turn it over, and you say, all right, here you quench your thirst.
Yes, sir. The thing is, rainwater, then use and make your water, the chlorine water, sir, in the pipe.
Well, yeah. Well, turns out that they have many different sources though. Mandeville water is actually good water though. Mandeville water is different from Kingston water. If you have ever tasted both water, even Portmore water different too. You even taste water in those two parishes, they taste different.
And yes, some people use seawater to serve. A lot of waters may have.
Yeah, well, them alone, right? Them alone. Then, well, they say they do in some countries, but that's a different story. But yeah, in Jamaica here, our rainwater, well, our parish water is actually in Manchester. It is from underground wells. And the good thing about Manchester is that our water passes through the rocks below the ground. And so it helps to filter out the water. And so, like where Benito said last week, him have a little spring up where him live near Lincoln, wherever. Yeah, you can get a nice spring water there. And you say you drink it directly, Benito?
Yes, sir.
Yeah, good. So look at that. And you seem pretty healthy. We don't see nothing happen to you since you come to class or anything. All right.
Water.
Right. And if you're sick, it's not the water sick, right?
No, sir.
Yeah, right. Probably COVID or something else. So the point is that the water is good. And in Kingston, however, their water comes from recycling sewage.
The water tastes bad.
Yeah.
Sir,
Of course, they recycle sewage.
It tastes bad.
Yeah, it does. All right, Tracy Water. What is the purpose of a water treatment plant at NWC?
Treat dirty water.
Right. Two things happen there. One, the water that comes there is connected to the sewage system. All right. That's how the drainage take place. And two, what leave behind when you separate the residue, which is all the filth that is in the water that is recycled, that part can be used to make fertilizer. You can bag that up and you go use that fertilize some farm, or you sell it to agro-grace or something. All right. And you get this stinking fertilizer which costs liquor or nothing. And if you're planting a big farm, you use that. So that's what happened at the water treatment plant. You get that as well as the water that comes through now is there for treatment. Yeah, so check it out. You actually use sewage water in big cities.
So it's somewhat of a filtration process, sir. Water treatment.
It is filtration. They don't use distillation. They use like filtration on different scales. So imagine this. You have water in the kitchen. Imagine that you use like 3 or 4 different strainers to strain it. But each time you strain it, you use a finer strainer. All right, a strainer with smaller hole. That's how them purify our water. So you purify it, you use a big strainer, then next time you use a smaller one, then until you get to the smallest level now. And that is very natural. So that works. And that kind of preserve the naturalness of the water when you do it that way. So people use spring water in the country. Yeah, that's good. That's what nature does. Yeah, water pass through a stone and rock and filter out and so on. So that's good. You still have your bacteria in there, yes. You still have human waste and so, because remember people still build pit and them thing there too, so water flow through there too. But at least you rely on nature to do the filtering. All right. Whereas when you reach up to people who sell water now, like iCool and so, it should be interesting to go to one of those factories and see what they do. But what they simply do here is the same thing. Now they can use chlorine as a last stage. Remember, after them clean out everything, the chlorine is there to kill any excess bacteria. All right. But another thing they can use is something called ozone, which is basically an oxygen derivative, where actually you can pass the water. It's actually a UV technique where they use, and them send the ozone through it and it filter the water. Now the advantage with that is that it adds oxygen to the water, and so it doesn't have the chlorine build up. So maybe that water now you can use like rainwater. Then call it RO water. It's RO water. Don't know if you ever hear that term before. That's actually reverse osmosis water. So that one is actually a little bit better than the pipe water. But pipe water gets it's overrated. People can drink from them pipe, yes, but then you're taking in things, you have to go through that still. But just saying that is the chlorine that you want to run from. So now with this process of separation there, they are using a technique where they evaporate the water and leave behind the residue. Gennaro, you mentioned people using salt water. You'd have to go to a country like Israel, for example, and even Bahamas and Cayman. Those countries, they actually do something called desalination. And for that process now, you're going to need heat for that, because you're going to have to remove the salt from the water. So you make the water evaporate, leave the salt behind, and purify the water that evaporate. So if you have been to Cayman or Bahamas, those flat countries where they have a lot of sea there, that's the only source of water they have. They're not blessed like us. They have rivers and so and springs. So they have to use salt water. Now distillation would be ideal for them. And if you have been to those countries, you realize how expensive water can get. It does add up there. Jamaica water is a lot cheaper and better as well. In fact, if you test our water is even better than in the US. In the
So I
most,
heard that a metal come out to your water, sir. And you find lead
yeah,
or
man.
something.
US you use all kind of thing in the environment where absorbing the water, and then by the time you get it through the pipe, you get whole heap of toxin, and you know everybody are gonna mash up because the main culprit in water in the US in a lot of states is lead, and lead accumulate and cause retardation in the brain. And luckily in Jamaica we don't have so much of the lead there, but just to show you that purifying water, your technique is very important. It affects the taste and it affects the benefit to living things. All right. And so whereas you probably can't tell the difference because you're looking at something colorless, the plants will tell you. So anytime you want to test water, you try it with plants a couple weeks and see how them respond. If them grow up nice and green and pretty, say yeah, the water good. If it's good for the plants, it's good for you. All right. And if it's not good for the plants, it's not good for you. Yeah, simple as that. So that's the water story there. So looking at the screen though, they said here it's used to purify a liquid by separating the components. Let's see a little bit more on how that is done. All right, so let's continue.
With mixture.
All right.
Let us perform an activity to understand simple distillation.
All right, so stick up in there, guys. What they actually have is a setup there. The setup, as you can see, you should be familiar with this. It's similar to the diagram that you guys looked at in the last class. This time it's more animated, but you're expected to know the parts or the name of the equipment that used for distillation. Now, you seen the cursor on the screen?
Yes, sir.
All right, the pointer. All right. Now, what device is the pointer on now?
Bunsen burner.
All right. See, it's one of those things that you have to make a note of in terms of if you have not been exposed to chemistry labs in real life, this definitely is something that you must know. This is a Bunsen burner, but then you don't have to use a Bunsen burner. You can use anything that can supply heat, but then more on that later. This device now that is connected below this flask here. Anybody know what this would be called?
I think it is a wire gas.
Wire gas. All right, yeah. So those are parts that you would need to know. So the wire gas, yes, it's indeed correct. But it is supported to this stand here by something. You know what name I give to the device used to hold things onto a stand?
Clamp.
Sir, is it a retort stand?
Yeah, well, no, and I asked what the name of the stand. I'm asking you what the name of the device used to hold like this wire gauge here. You hold it onto the stand using what you say, a clamp. Yes, so you'd clamp anything you want to support on the stand. In this case, you would use a clamp to do it. So we have a clamp there. So Bunsen burner, and I'm going to write the names of those when you finish. But Bunsen burner, named after Robert Bunsen, who discovered that thing back in the 18th century. And then we have the wire gauge here connected with a clamp. And this stand that we're looking at, this tall stand that has 3 clamps on it, is called a retort stand. And that's RETORT stand. All right. Now we're going to talk more about the apparatus later, but I want you to understand the process. So it's the key here. Understand. Well, this little glass tube here. Anybody know the current name for this thing that has the water looking?
There is it distillation flask.
Distillation flask. All right. Actually, you probably will get away with that, but you'll get away with writing that at CXC level, especially. But that's not the right name for it. What adjective would you use to describe the shape of it?
So a round base,
All right, so so it's considered, it's called a round bottom flask. All right, so yeah, it's right. So we'll talk more about this later on though, but just get familiar with the apparatus. Then that's key here. All right, because CXC could ask us in a question saying how would you separate some mixture, and then you would have to know the steps. And this is the apparatus is one of the things you get marks for. All right, but you could get a plan and design lab as well, and they ask you for something like this, which is very likely. So this is the round bottom flat. That's what the cursor is on. This pointer here. All right. At the top of it, of course, you see a clamp holding that up. All right, and the clamp is where the pointer is on now. All right, but there's something at the top here. This, what color this look like? A brown looking thing. All right, the brown looking thing at the top of the flask. Anybody know what that is?
Cork.
All right, cork. All right. No, not technically. No, that's not the appropriate name for it. All right, that part is actually a rubber stopper, a rubber bung. Yeah, it's actually a rubber stopper. It's important that it's made from. Well, you could use cork though, still. No, cork is a more rigid sort of wooden thing that they use instead. But this rubber stopper though is the ideal thing. All right. Although the rubber stopper after a while it can it can start pollute the container. But again, rubber stopper is in most labs you'll use. And the reason for using a rubber stopper is that you can actually bore a flexible hole at the top. And this device is placed in there. This device with the red tip here. What is this called?
Thermometer.
Yeah, very good. It's a thermometer. So this thermometer is actually placed inside the rubber stopper. So the rubber stopper, because it's rubber, it's flexible, so you can just push the thermometer right through it and it hold it. But it's actually hard rubber, and then it holds the thermometer in place. All right. Then of course this part now is like a spout here, and it's connected to another device. All right. No, this is the main part here. And notice this is simple distillation. You only really need to remember three important apparatus here. Simple distillation, that's why the name suggests you use more simple equipment. This part here, so the blue, and this part with the blue connected this part with the rubber stopper here. All of it is one device. What, anybody remember the name or think they know the name of it?
Yes, sir.
Yeah, very good, Casey. You're saying condenser?
Yes, sir.
Yeah, definitely that's a condenser. All right. And of course, this is where the condensation takes place. The two vents are there. One is to intake water, so that's the spout here, and the other vent is to release the water. So the water just basically circulate this tube. As the vapor passes and the water circulates, now it cool down the vapor and make it drip. And notice that this is actually tilted downwards, right? It's to actually speed up that process. So typically, this is definitely this is a ideal apparatus for distillation. So the main pass for distillation is the flask. All right. Benito said distillation. What you say? Distillation flask, you say?
Yeah.
The entire thing is commonly referred to as distillation apparatus. So in case you're in an exam situation and then ask, how you separate, like a mixture of salt and water, sugar and water. Well, you're gonna say you're gonna use the simple distillation. And then now, if they ask you to explain or describing means the steps that you take. You simply say that you're gonna set up your distillation apparatus. That's a collective term for what we're talking about here. All right, distillation apparatus has this flask here. It has the condenser here, and also it's gonna assume that you're using everything else. So therefore, all of it is a distillation apparatus. However, the specific name for this flask could be the round bottom flask, or you could get away with distillation flask at CXC level. And this is the condenser, and this is your receiving flask, which is usually a beaker here on the right hand side here. So that's pretty much the setup. So let's see where this video is going with it. All right.
Take a mixture of acetone and water in a distillation flask.
Now stick up in there. So they're actually wanting you to separate water and acetone by simple distillation. This is interesting. As if you check more sources, you use simple distillation when the two objects you're trying to separate have far boiling point. The boiling points are totally different. So we all know that. Anybody remember the temperature at which water boil? Not making any assumptions here, but at what temperature would water boil?
100 degrees, sir.
All right, very good. That's Gabby. Yeah.
Yes, sir.
Very good. That's 100 degrees Celsius. That's the boiling point of water. Let's check the boiling point of acetone, because it's interesting that they would use simple distillation for this setup. And if that's the case, I would have to change this video, because they would be misleading you here. This is the boiling point of acetone. If it's too close, then we can't use it. Water is 100 degrees. What is the boiling point of acetone? Turns out acetone, I don't see any boiling point here. Boiling point is 56. Okay, so it could work. It could work. 56 degrees Celsius, guys, or 57. So acetone boils at 57 degrees Celsius. Water boils at 100. So this can be used. I was just about to flag this video, but it's cool. 56 and 100 is far enough. All right, that's about what, 44 degrees difference, so it will work. All right, let's continue. So them say take a mixture of acetone and water and put it in the distillation flask. All right, fine. Let's see. All right. This is it. All right. So they refer to it as distillation flask. All right, work with that. Then you put it there. All right. So they live in the apparatus here.
Put a thermometer in it.
You see the thermometer there. Right, let's set in Lamar. So Lamar having problems connecting.
Connect the flask to a water condenser. The condenser has cold water running through its jacket to keep the temperature cool. Keep a beaker at the outlet of the condenser. Heat the mixture, keeping an eye on the thermometer. When the temperature hits 56 degrees Celsius, acetone starts to vaporize.
All right, so stick up in there. You see that? You see what's happening? So they're giving you all of these pointers when you're doing distillation, right? Note that the temperature at which one of the substances boil. Remember, I use it for solution, by the way. So in a solution, you have a solute and a solvent. And now, whichever one has the lower boiling point, that's the one that will be separated first. And that's a given. So 56 degrees is what they use for acetone. And say keep an eye on the temperature. All right, that's why 56 degrees.
These vapors condense in the water condenser. The condensed acetone gets collected in the beaker. When all the acetone vaporizes, water is left in the flask. Acetone is collected in the beaker. In this way, acetone and water get separated by simple distillation.
Everybody see that? All right. So
Yes, sir.
that's simple. That's simple enough. So just remember that this would be ideal. They're using it for water and acetone. Again, it's interesting though. If you got salt and water to separate or sugar and water to separate, you could use distillation for that. However, I think I think one of the drawbacks with using it for something with solid is that what they you have to get out the solid through the hole here. And so most of the time they recommend that you use a liquid solution. So two liquids mixed together for this process. However, you can actually use solid though, but I mean purity is a factor there. But still. So that's pretty much the video. I don't think there's any other thing there. I guess we could finish watching it and see what else him say.
Ah.
Huh?
Right.
Boiling point of water is 100 degrees Celsius. Boiling point of acetone is 56 degrees Celsius. As there is sufficient difference between their boiling points, these components can be separated by simple distillation. Simple distillation does not work properly when difference between two boiling points is less than 25 degrees Celsius. This is because the components do not get separated and purified completely. If we repeat this process multiple times, we will be able to separate these two components. However, as this is very time-consuming, a special type of distillation called fractional distillation is used.
All right. So they introducing it there to fractional distillation. Again, you use fractional distillation when the boiling points in a mixture of the components in a mixture are close together. All right. So when you mix a solute and solvent together and you check it out, the two of them have close boiling points. Example, alcohol and water. Then you wouldn't use simple distillation for that. All right. You use fractional distillation now when the boiling points are close. Everybody get that? All right.
Yes, sir.
Make sure you remember that, you know. So when the boiling points have two parts of a mixture are close together, we use a fractional distillation. But when the boiling points of the components in a mixture are far apart, then we use simple distillation. All right. So that's the key there. All right. So let's go back now to original screen. I'm interested now. Let's go back here. All right. So again, it is used to so you use to separate where the solute and solvent, all right, have a boiling point. that are sorry, we should say boiling points, and so that are more than all right. So example here, we can use our acetone and water. And another name for acetone is what? Nail polish remover. So you could mix this in water and try to separate it. We have others as well. Anyway, acetone and water is a given there. All right. Now, if you say alcohol and water now, the boiling point of alcohol is 78 degrees. Which means that you couldn't use simple distillation for it. All right. So let's put simply here. And we're referring to simple distillation there, as of course. But then fractional distillation is the other part now, and this is something that you'll see throughout CXC because well, one, this is a distillation that's least done throughout the schools, and also two, because Trinidad actually set most of the questions, or at least they have a big part to yes.
You can go back on the next slide for me, please.
All right, next slide. Let's go. This one.
Yes, sir.
All right. So I'll take care of simple distillation though. But I'm saying that Trinidad does have an influence in what happens in the CXC exam. So Trinidad is a country that make that have a cane industry, and so them do distillation regular. A lot of industries there do distillation. And them also, because them have the oil and the tar and them oil purification business there, them are actually they're very big on distillation. So, and it coming like from time to time, the students in Trinidad get to go on these trips. They go to the part where purify the oil and them see the distillation tank, and them get to go in and ask questions, and so they exposed to that. The only place we can go for that sort of thing is where? Petrojam. All right, and we know Petrojam go already. All right. Petrojam has been scandalized, but aside from that, Petrojam is way in Kingston, and so it wouldn't be feasible for us to say we're going on a trip there. Bear in mind that we'd have to travel there, and it would be a whole day thing, and some of you guys work and all that sort of stuff. And if you go to Petrojam, might as well go some other place to where the syllabus recommends we go, like on sugar factory. If you follow the syllabus word for word, we should have go to a sugar factory, we should have go to a rum factory, we should have go to a Petrojam, right? Which other place I want to go now? We're supposed to go like Windalco or them place, them backside plant there. We'll go so many of these places, but when would we get time to do SBAs and meet for class and work past papers if we were able to do all of that? It would you'd have to be like doing chemistry alone, So the persons who do further studies in chemistry have to do that though. But just saying that, just imagine yourself at these places, or you can ask questions, or most you can do is watch some video and discuss it, But that's distillation for it. Distillation is very big in terms of chemistry overall. So it's something that we have to kind of know well. But the key is to understand that it's just evaporation and condensation. So all right, so we're almost out of time. But then for next class though, we're gonna look you want to definitely look at fractional distillation some more though, in detail, because fractional distillation now is how we can get some of your guys' favorite beverages, especially when you're partying or you're socializing. You definitely want a little bit of alcohol, and wouldn't have that without fractional distillation. So that's our next topic here. All right, well let's look at a setup though. Before you guys go, in fact, this is not a good diagram. Let's find even a better one. Want something that's like kind of simple, but at the same time give you all the way you're supposed to get. And here's fractional distillation. Okay, well, this could work. Let's try this. All right. Let's look at this one, and let's probably expand this. Again, the example here, same evaporation and condensation. However, the one difference in the setup is which device? Which one is in this one that's not in the simple distillation? All right. Let me give you a better image. Yeah, here you go. So let's look at this setup. For the fractional distillation, what is the main difference you see here? Look at the main. The what?
Fractionating column.
All right. Everybody seeing that? This part is the difference. Fractionating column. So that's what makes it fractional distillation. All right. We use the fractionating column between the flask and the condenser. All right. So in other words, for fractional distillation, the mixture has to evaporate through a fractionating column. And as the name suggests, fraction means to what? To divide, no? So you divide it up. So so usually what happens is that when it evaporates, the lighter one evaporates first. Even if some of the water goes up through here, because it's heavier than the acetone, it's actually gonna go back down into the flask. But the acetone is light, so it pass through these little you call them here beads, and then they will acetone. So this is actually better, give you more purity as well. But it takes a little longer in a sense. But then so you're going to evaporate and come through, pass through the column before it reach the condenser. All right, so that's the main difference. Again, we use this for separating. Solution components with close boiling or having, let me just change the language here, having close boiling points. They use acetone here, but you can use it for acetone. The only reason they would use it for acetone though is to increase the purity of the acetone. So it's as I say, it will work, but if you want better results from distillation, the fractional method is actually better. It gives you more purity. If you do simple distillation, water and acetone, you'll get the same result. However, the acetone in the simple process would not be as high a quality or purity as when you use the fractional method. So it's a similar thing there. All right, so yeah, that's pretty much it. I think I don't know you ever hear about JB rum? JB rum versus Appleton. Which one you think it tastes better? If you ever drink them. No, nobody know.
But sir, when I write rum, Appleton, white rum.
All right. Ray and Neville or JB then?
Ray nephew.
Them taste the same?
No, he have a different taste.
Them smell the same?
Somewhat.
Interesting. All right. Which one more expensive?
More expensive what, sir?
I
The
think Ray
JB,
nephew.
the JB or the Ray and Neville? Which one more expensive? We're saying. You say
Ray nephew.
Ray and Neville? For the people who don't know about liquor. All right, yeah. We have to find out is that the Ray and Neville it's you know they go through better distillation than like a JB. So therefore that's one of the advantages here. You ever hear them talk about Kulu Kulu rum?
Yes, sir.
Yes, sir.
Yeah. All right, so that's the cheap rum, right? They call common rum where them not really distill it properly, so it have impurities in there. Right? Make it harsher. So the difference between like something like a Kulu Kulu and a Ray and Neville is the purification using the distillation. One of them actually go through a higher standard of purification, and so that explains the difference in taste and in quality. All right, so we're going to talk more about that still next class though, because that is within fractional distillation. All right, so if you guys don't have any questions, we're going to stop here for today.
Sir.
And then, yes, question?
Last day is something about P&D lab.
Yes. So there would be a P&D lab for separating techniques. However, we would have to learn a couple more though before we can talk about that. All right. So more on that later though, but there will be a P&D lab on this topic. There'd also be a carry-out lab as well, because you have to do filtration on your own. The question is, can you get the devices? Can you get the equipment to do it on your own? The idea is that you guys would need to have access to the coffee filter, which coffee filter, I'm selling it at supermarket. So I don't know if you guys can reach a supermarket. Just wear a mask and walk with a little money. Let me see something like coffee filter, which just looks something like this. And I'm showing like an image on the screen in case you don't know. Let me sell like 100 of them in one pack for cheap. All right, I still like this. So be like your coffee filter there. All right, that's what it look like. This can do your filtration. You don't need nothing more on this. All right, so your coffee filter. So if you not can get to no hands on this, guys, then we can do the lab with the filtration. All right, so that would be second lab, and then of course next class we run through filtration. After that we have chromatography to do, which is the third, which would be what the fourth one on the list here. Yeah, and you see me put an asterisk there because this is crucial. You can use the same filter paper to do this lab. So when you buy the coffee filter paper, you can actually do 2 labs with it. All right, which would bring your number to 3. And you afterwards now you're going to get the plan and design lab now, where you combine all of the techniques together to solve a question that you'll be given. All right, so that will carry up to 4 labs potentially. So get the coffee filter paper and then we can talk business there. All right, so that's a crucial thought here for you guys. So that's it, guys. Any more questions? All right, guys. So no, that's it. All right, so I will see you guys on that would be on Wednesday. All right, and
Sir.
and yeah, until then, enjoy the rest of your evening.
Thank you, sir.
All right.
Yes, sir.
Yeah, no problem. So